Action 1, Inspiring Next. Action 1, Inspiring Next.
Look up because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action One Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very, very important to me. And I feel like Action One Media's goal is aligned with mine. So together, we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time. Look up because you never know what you will see.
All right, everybody. This is Shen Ge. I am not even sure what episode this is since I've been out for 2 weeks. 41, according, or 44 officially. 46. I think I finally got it. I think it's 46 now. All right, so my apologies. Last week, as some of you may have, if you're from Houston, if you watch the news, you may have realized that half the city got flooded, and I did not want to risk being one of those stranded cars on the road. So the week before that, for you guys who also paid attention to the news, it was the election debate for the Democratic candidates here in Houston. So it seems like Houston has undergone quite a lot of things on Thursdays, which is why I do the show. So, all right, I'm going to blame it on circumstances. So, I'm actually, even though the weather outside is pretty good right now, I'm feeling a little under the weather. So apologies if I cannot display my normal hand waving and shouting kind of enthusiasm. So it would be a little toned down. But, still, it's me, right? So space is exciting. SG2 on Space, the only weekly space show here in Houston. Although, like I said, we did skip the last 2 weeks. So featured on Action One Media, as you can see behind me, Action One Media Studio. We are a1.com, SG2 on Space, which you can follow at facebook.com/ The Shen Show, or find us on YouTube. Just search for SG2 on Space. Okay, excellent. So, figured, as always, let me start out. Okay, so the theme for today I want to talk about is telescopes. That's actually what I wanted to talk about 2 weeks ago, but, hence the delay. There has been some new recent happenings in the space world because things happen in 2 weeks. Things always happen. So, I but primarily what I want to talk about today, though, are the things which I did some research on a week or two ago on various space telescopes and what they have uncovered. But on other notes, I might as well tell you some of the other happenings. For instance, India did locate the Vikram lander, which was supposed to land on the moon, right? And unfortunately, it failed. So thankfully, the orbiter is still fine. So despite the September 7th loss, India's ambition to take its place among the spacefaring nations, to look at, to look at the moon, is still happening with the orbiter Chandrayaan-2. So, however, it does make it that harder to actually find stuff when you don't have something on the ground that's working. Unfortunately, hopefully next time will work. I mean, I'm always feel the loss when something doesn't work, especially for lunar exploration, which I feel like is the next step. And other things, the first United Arab Emirates just launched to the space station, which, considering this country, UAE, I don't think had a space program 5 years ago. Definitely less than 10 years. That's a pretty big deal. So UAE, United Arab Emirates, has just sent its first astronaut into space. And they're only going to be, his name is, can't say Arabic, right? Hazar al-Mansouri, former Emirati F-16 pilot, and he launched at 3:42 p.m. Eastern Time on September 26, 2019, which is, September 25th, which is a pretty big deal. All right. So he's going to basically perform a series of experiments and conduct a tour of the space station in Arabic. And, of course, in case you guys don't realize, UAE is not one of the countries which put in money to build the space station, obviously. So, anyways, but it's a pretty big deal considering, there's other countries that's jumping into the space, into the space arena now. So, these guys, they purchased a seat from the Russian Space Center, Russian Space Agency, I'm sorry. So seat on Soyuz. So the Russians are perfectly willing to, send you up if you have enough money. So what other plans does UAE have in space? I might as well talk about this because it's kind of interesting. A lot, apparently. NanoRacks, for instance, one of the premier small satellite companies that's based here in Houston, Texas, they announced last week, so mid-September, in other words, that they will be opening an office in Abu Dhabi, the largest emirate of the UAE. So Euroconsult, an international consulting firm focused on the space industry, they reported that the Emirates spent nearly $383 million on space last year. That's obviously less than the $41 billion spent by the U.S. or the $1.5 billion by India or a similar amount by China, but it is more than what Canada spent, which is pretty amazing. So next year, the Emirates are going to launch its first Mars mission. That's right. So for a space agency that's less than a decade old, they're already going to do Mars, which is pretty insane. All right. So the Emirates are going to launch its first Mars mission, a spacecraft called Hope. The probe is going to go on top of a Japanese rocket, and it's going to carry 5 instruments that's going to study the loss of hydrogen and oxygen from the upper parts of the Martian atmosphere. So for Hope, Emirates is working with University of Colorado, Arizona State University, and University of California at Berkeley. So in any case, so that's pretty cool. Just a note, though, the Emirates, they are not the first Arab to go into space. That honor goes to Sultan bin Salman Al Saud, who's a member of the royal family of Saudi Arabia. And he went up into space in 1985, and there was also Mohammed Ahmed Faris, a Syrian military pilot who flew to the Russian Mir station in 1987. So, but this is the third and the first for the Emirates, which has big goals, which is amazing. Okay, so before we go off into our wonderful break era, actually, all right, you know what? Might as well. And I'll turn to this book later today as well. So every time I'm going to present a book, right? So this one is called Aliens. Already that attracts my attention. When I see aliens and ETs, it's like, boom, must get it immediately. And that's what happened with me, right? I'm sure everybody feels the same way. All right, so Aliens, the world's leading scientists on the search for extraterrestrial life, edited with an introduction by Jim Al-Khalili. Guess what this book is about? Aliens. All right. Okay, obviously. So it's pretty cool because every chapter is written by a different person, whether it's an astrophysicist, astronomer, psychologist, even historian, stuff like that. So, for instance, I mean, there's a chapter. I'll read some later when we talk about stuff out there. So, for instance, there might be stuff like, "Hey, abducted: the psychology of close encounters with extraterrestrials." I mean, that chapter is like, oh my gosh. Or it might be something more, physicky, like further out. Could the moons of the gas giants harbor life? I mean, that's pretty scientific. Or Alone in the Universe, The Improbability of Alien Civilizations by Matthew Cobb. Okay, I totally do not agree with that guy, but hey, you get all sorts of views in this book. But anyways, very interesting read. I've been jumping around, which is, what I do. So, all right, let's take a quick break. When we get back, let's talk about some space telescope stuff.
Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm in the presence of like celebrities.
It's just the shades, man. Shades.
So I think like 2000.
Put your money where your community is. Get in the action. Action One. Independent thinkers working together. Inspiring action in media. Get in the action. Inspire today. Join us by being a sponsor at weareA1.com.
In south central China, something incredible is being constructed.
我们人类文明的风景。
To see this thing emerging out of the landscape, it's absolutely fantastic.
China is building the largest telescope in the history of mankind. When in operation, FAST will be able to detect radio signals thousands of light years away, at the edge of the universe.
The first word that comes to my mind is mind-blowing, just a mind-blowing concept.
It is set to rewrite our understanding of the cosmos as we know it.
It does provide almost a quantum leap in capability.
FAST is destined to answer some of astronomy's biggest mysteries.
探索宇宙起源、天体起源和生命起源。
Are there other intelligent civilizations out there?
In remote Guizhou, a 45 million year old crater has been selected to house a man-made marvel.
我们的发斯特台质大窝囊挖坑，是我们总。
So we are back. You're listening to SG2 on Space, episode 46. As noted, the only weekly space show here in Houston, although we did have a hiatus of 2 weeks, and clearing my throat to indicate lack of ability to talk loudly due to probably slightly sick. Anyways, point is, with the energy I have, I am fairly excited to talk to you about the space telescope named FAST, which stands for the 500-meter aperture spherical radio telescope. I want to bring it to your attention since I don't feel like, unless you happen to be in the space field or read up on stuff, it's not typically on the news here, which is a shame. I think many of us have heard of the radio telescope in Puerto Rico, Arecibo, right? In fact, I think that was in the James Bond movie, GoldenEye, if you remember that giant dish. I think that was the one. But anyways, that one is, okay, so radio telescopes are necessarily humongous, right, to capture the long wavelength, all right? So, but the largest one, that used to be the largest one in, called Arecibo. The largest one these days is actually in China, the 500-meter aperture spherical radio telescope, which is 500 meters in diameter, versus say Puerto Rico's, which is 305 meters. Okay. All right. So FAST is made up. Just give you a few facts. And by the way, the person talking over there was essentially the originator. Yeah, the originator of FAST. He actually passed away. But his dream was realized, which is good. So, anyways, so FAST is made of 4,450 individual panels, and it's actually cradled in natural basins. So they did not have to blow up that thing. All right, so it's naturally half spherical. In Guizhou, which is in southwest China. So it is a fixed 500-meter dish. It can't be aimed. But it is, it's the world's most sensitive listening device. And it's also the world's largest filled aperture radio telescope. So the Russian has something called a Rayton-600 radio telescope. It's a different type of design, and although its footprint is larger, it's not as sensitive. So now this is exciting news I'm talking about. Recently, actually just 2 days ago, September 24th, 2019, Nature magazine, one of the most premier magazines, just featured an article here. So basically FAST is actually preparing to open its doors to astronomers all around the world. So this year, it's been testing stuff to make sure that it works properly, right? So they have just passed a series of technical and performance assessments, and the Chinese government is expected to give the observatory the final green light to begin full operations at a review meeting scheduled for next month in October. And Di Li, or supposedly the chief scientist of FAST, she says, we do not see any roadblocks for the remaining transition. I feel both excited and relieved. So, in any case, this telescope's massive size means it can detect extremely faint radio wave sources across the universe, such as spinning cores of dead stars, known pulsars, right? Hydrogen distant galaxies. And it can also use radio waves to locate exoplanets, which is crazy. That's pretty cool. I did not know that. So, now, during just the initial testing phase, the telescope has discovered more than 100 pulsars. So, for instance, in August and September this year, 2019, the instrument detected hundreds of bursts from a repeating fast radio burst FRB source known as 121102. And a lot of these bursts were too faint to be seen, to be detected by other telescopes. So, this is very exciting news because no one knows what causes these mysterious bursts, all right? But the more data we have, the more we can learn about them, right? So, and who knows? There might be aliens sending signals. You don't know, or it might be some other natural phenomenon that we haven't been able to try to, we don't know what it is yet, how to explain it. So, now notice that FAST only examines a very tiny part of the sky at any one time, so it's unlikely to discover many more FRBs. But the telescope has very impressive sensitivity, so it can follow up on sources in detail. So other telescopes can maybe detect those, and then FAST can maybe look at it. So, also FAST is trying to look at ripples in space-time. So the International Pulsing Timing Array is using radio telescopes around the world to monitor regular emissions from pulsars, which are spinning neutron stars, right, and the send-out pulses. So looking for distortions that will reveal passing of low-frequency gravitational waves, which I will talk about what exactly that means shortly on these gravitational waves, since that's something that is really interesting. So, hold your horses. Gravitational waves will be discussed. So, okay. All right. So, as one of the most interesting things is that right now, no exoplanets have been conclusively detected by radio emissions. But FAST's ability to spot faint polarized waves may give it, the ability to do what other radio telescopes can't. So, No, polarized radio signals. Where would that come from? That would come from planets with magnetic fields, kind of like Earth, right? Which you want a planet with a magnetic field, by the way. Why is that? Because it protects life here on Earth, say, against harmful radiation, right? And keep the planet's atmosphere attached. That's why Mars doesn't have an atmosphere anymore. It's not because it's further out from the sun. It's because it doesn't have a magnetic field, okay? And it has smaller gravity, all right? So the atmosphere was going to leak away anyway. But point is, whatever solar flare and stuff, interacts, if we get a full blast of it, it would just strip away our atmosphere. Thankfully, Earth has a magnetic core, has an iron core, which is spinning, and so sloshing around, and it has a magnetic field, which protects us from these particles that would otherwise have stripped away the atmosphere. So it's quite important, and thankfully, these polarized radio waves, they are naturally going to have to come from planets with magnetic fields, all right? So Lee's team, in order to identify a planet, in order to boost that, they're going to add 36 dishes, each 5 meters wide. So those dishes are pretty darn cheap off-the-shelf products, but together they can actually improve fast spatial resolution by 100 times, apparently. I'm not sure how that optics works, probably some interferometry thing, I don't know. So, okay. Anyways, this is going to be really interesting, guys. So, looking forward to it. All right. So, I told you what... Excuse me. All right. So, there's also something else that's really exciting. A new interstellar comet has been discovered. And that's right. It is official. It is an interstellar comet coming from outside of our solar system that have entered, and it was discovered by just, once again, purely by accident. So if you recall last year when Oumuamua, which is a really funny name, when that really long, oblong, pencil-like shape, which I kept saying could be a UFO or extraterrestrial object. Anyway, point is, when that came into our solar system, everybody was surprised, and unfortunately, people discovered it right when it was leaving the solar system. So we really couldn't take many pictures or observe it, right? So this comet, it was spotted at the end of August, and now it has been declared officially an interstellar object, according to the International Astronomical Union, IAU, which is essentially labels and names all astronomical objects. They're the official body. So the verdict means that the object, provisionally called Comet C/2019, now dubbed 2I/Borisov, BORISOV. Why does it have a 2I? Well, aren't they creative? It means second interstellar. Okay, so it's the second interstellar object that have been identified. So the first was 1L/Oumuamua, which was spotted in October 2017. Okay. So the IAU wrote in a statement, the orbit is now sufficiently well known and the object is unambiguously interstellar in origin. It has received its final designations as the second interstellar object 2I. And the name Borisov honors its discoverer, who is an amateur astronomer. You guys, amateur astronomers, you guys can go out and take your own backyard telescopes and look at stuff, which is kind of cool. Okay, it doesn't mean that you don't know what you're doing. It just means you're not funded by a university or a research institution, right? You're just doing it because you enjoy doing it. So the name Borisov honors its discoverer, Crimea amateur astronomer Gennady Borisov. So IAU held out for this official declaration until September 24th. So how do they know it's interstellar? Well, they tracked the comet's location to confirm that it has an extremely elliptical orbit. Okay, so if it's within the solar system, it won't have that type of orbit. Actually, sorry, let me change that. Hyperbolic orbit. Elliptical will imply that it's going around the sun. So it's hyperbolic. It comes in and then goes. All right. So basically, it just passes through our solar system. So it has a more hyperbolic path than any other comet scientists have studied to date. Okay, so when is it going to make its closest approach? Well, on December 7th, the comet this year, December 7th, the comet will swim past the sun at a distance of 186 million miles. That's 300 million kilometers, which is basically about twice as far from the Earth as to the Sun, which is not that far away, okay? So around that time, the comet would become visible from the southern hemisphere. So unfortunately, me up here cannot see it. Nobody in the U.S. could see it. Go down to Australia or something, or South America, or somewhere in Africa, all right? Or India. Okay, anyways, that aside, if you go to the southern hemisphere, you'll be able to see this comet around December 7th. All right, so around December, okay, you can also see it in January. And it's going to remain observable until 2020. That's pretty amazing. So you're going to be able to, look up in the sky and just be like, oh my gosh, this is a comet. And it's gone forever, like in a few months. It's out of our solar system. That's pretty wild, So, what I just thought would be funny is if one of these interstellar objects like hit Earth or something. I mean, that would not be funny, but it'd be like, where did that come from, It's like, what the heck? Like some object from outside of our solar system? How are we supposed to even predict that? Actually, you can't. When do you know these things will happen? You can't. So unlike stuff in our own solar system, there's really no way to predict when you're going to have an interstellar object come in, right? So the cool thing is you can even go online right now, and there's pictures on there. Like you can go to, for instance, virtualtelescope.eu. So, and there's images taken by various astronomers around the world, since now that everybody knows it's there. If you have a decent enough telescope and a camera, you can take pictures, all right? You can easily track it. So, I mean, right now it just looks like a faint dot, but hey, that's the best we can do right now. It's still pretty cool, though. All right, so what else? Apparently, I want to talk about, so we were talking about pulsars, right, with a fast telescope. So, about 2 weeks ago, the most massive neutron star has been found, all right? So, you might be thinking, all right, neutron stars, what is that? And this guy keeps mentioning pulsars. What the heck is that? All right, so apologies for mentioning stuff without explaining it. So neutron stars are basically the end states of massive stars that have spent their fuel and exploded. Okay, so for our sun, it's not large enough to turn into a neutron star. It'd just be a pretty lame white dwarf. Lame meaning, okay, it's not an exotic form of matter. Okay, but neutron stars are really exotic. It's literally a star made entirely of neutrons. No protons, no electrons. Because the strong force pretty much dominated everything. And if protons and electrons, I believe those two combined actually, what is it? Anyway, point is, at a certain point, you can't possibly have protons and electrons. Everything would be neutrons, okay, if it's packed that densely. So, now neutron stars, if their stars are any bigger, it won't become a neutron star. It will become one of the stereotypical things known as black holes, all right? But neutron stars are very interesting themselves. All right. So there's astronomers in the National Science Foundation's Green Bank Telescope. They found the most... Wow, isn't that annoying? They found the most massive neutron star yet. And this is basically... The star they discovered, it's called J. Man, I can never remember these names. Nobody can. It's J0740 plus 6620. How are you supposed to know that? Okay, so not a cool name like that interstellar comet. It's just a bunch of numbers in one letter. All right, it's 2.17 times the mass of our sun, and all that mass is jammed into a sphere about 30 kilometers in diameter. So essentially, like one little pinch of that is like 1 million tons. All right, so think of it, these are like city-sized objects, right? Like think of, say, the size of Houston or something, or except maybe even less, 30 kilometers in diameter. What is that, like 20 miles in diameter? So this whole thing is a gigantic like atomic nuclei. You can think of it that, which is pretty ridiculous. So this neutron star they discovered is a binary pair. and it's also a pulsar, right? So what are pulsars? Pulsars are basically rapidly spinning neutron stars, all right? So pulsars, neutron stars spin because of the really strong gravity and magnetic field. They end up emitting beams of electromagnetic radiation from their magnetic poles, and then these radio waves sweep through space as the star spins, right? All right. So then astronomers can detect them, and because they follow a very regular pattern, they can be used like atomic clocks, okay? So the astronomers can use them to measure the mass of objects in space. So the other star in this binary pair is a white dwarf, which is what the sun will become eventually. So in any case, this one is pretty cool because it just turns out that the white dwarf and the pulsar is exactly dead on towards Earth, so we can have a perfect image. I mean, we can measure the mass of the companion white dwarf star, the orbit common center of gravity, which we can figure out. So as the pulsar emits the radio waves, the white dwarf moves between them, and then we can figure it out. All right, I'm not going to go into the actual math calculation because that would require more than hand waving. So, all right, let's take a quick break. When we come back, I actually want to talk about some stuff about life and then some other things about really, stuff out there. So, out there, aliens. You know what I'm talking about. So, all right, take a break.
Man, you still here? Go on and subscribe.
Get into action.
Yo, we back at it again, baby.
What?
Get into action.
3.
Get into action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
Get in the action.
Tell me what is the deal. Cause I'm calling for you.
Get in the action.
Can you feel that? See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Can you feel that? See, I'm calling for you.
Put your money where your community is. Get in the action at weareA1.com.
Look up, because you never know what you will see. Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston, with Action One Media Group support every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. All that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me, and I feel like Action One Media's goal is aligned with mine. So together we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community. Tune in to SG2 on Space on Thursdays at 8 p.m. U.S. Central Time.
Okay, so, man, there's so many new topics. I was going to just rehash some old ones, but I got to talk to you about some stuff. All right, so first of all, W first, all right? So wide field infrared space telescope. So NASA's W1 space telescope, it used to be a spy eye. I'm going to say that because it used to not belong to NASA. It was but now it's given to NASA. So from I think the military. So essentially, this is basically it's going to use its instruments to to look out, right? So one of these instruments is a coronagraph that will allow the telescope to get a clear look at extrasolar planets. So more exoplanets, yay! More telescopes to discover them, also, yay! All right. So those instruments recently completed a preliminary design review, PDR, conducted by NASA, so which is a huge milestone in its development. And one of them, this coronagraph, is really important part of its planet hunting instruments. So ordinarily, directly imaging exoplanets is really hard because their parent stars are super bright and the planets obviously generate no light, right? And then, you know, how the heck are you going to see it? So, but a chronograph could cancel out the intense glare of a star, all right? So that way you can study the exoplanets directly rather than relying on indirect methods such as a transit method, which is, remember, I keep talking about TESS telescope, which has helped us a lot, but TESS can only detect it through something like the transit method. And what if it doesn't? What if the planet doesn't perfectly translate in front of the star? Then you can't use that, right? So by contrast, the direct imaging method, which W1st would be able to do, has many benefits, such as the ability to obtain spectra directly from the planet's surface and atmosphere. So this allows a much more accurate assessment of the planet's composition, right? And of the atmosphere and so on and so forth, which would be really cool. So I can't wait for this. The other telescope that's going to go up, that's much more expensive, is the James Webb Space Telescope, which is basically going to be, yeah, that would be huge. So that's undergone a bunch of delays, but it's going to launch in 2021, James Webb Space Telescope. So it will also have this technology, but it won't have the same starlight suppression capabilities as W1st. So while W1st will be the third flagship mission to employ coronagraph technology, it will be the most sophisticated. So this is going to be some real good science that's going to be found, hopefully. So, all right. The other thing is, speaking of detecting this stuff, all right, so as you can see, I've shifted to talking about searching for life and things of that nature, because that's always been of interest. All right, so there's also these things, maybe I mentioned this before, biosignatures and technosignatures, right? So today, stuff like that, there's something called technosignatures, which is defining stuff that can only come from technology, right? So there's several major classes of technosignatures, which actually this kind of telescope, if you use direct imaging, you do spectroscopy, you can actually figure out what elements there are in the atmosphere, for instance, if there is an atmosphere. So one of the technosignatures is chemical signatures, right? Such as atmospheric pollution. That does not come naturally. Look at Earth. All these chemical elements in our atmosphere, pollution, nature can never have produced it, right? So if we detect something like that, then we know there's an advanced life form, which unfortunately is still creating pollution, but hey, there's intelligent life on that particular planet, right? There's also, if you detect things which have weird, like light curves, right? So, or some strange kind of communication signals. So that could be indications of like megastructures that reflect, absorb, or block light from a planet's host star. Self-luminous signals such as artificial illumination, radio or laser communication, and waste heat, which is pretty much unavoidable for any kind of activity on thermodynamics, right? So now this particular team in Germany, actually, it's called Kepler Institute for Solar Physics in Freiburg, Germany. They're looking for optical signals. So as a planet travels around a star, the light is reflected by the planet changes, right? Depending on where the planet is on its rotation and its orbit. So researchers can create a light curve, and then they can get a glimpse of the planetary surface and any unusual features there. Okay, so this is an example of using that transiting method, all right? But which can still give you useful information. Point is, if you find any of this stuff, there could be indications that there's some kind of intelligent life form, right? So, speaking of intelligent life forms, one of the things that here in our solar system, which I found interesting, was about Venus, right? So, I mean, we all hear about, oh, go to Mars. Mars has life. But it turns out that Venus could have had life as well, given by the fact that, what is it? Men are from Mars and women are from Venus, right? Apparently nobody's from Earth. Nobody's from Earth. I don't know why. Maybe kids are from Earth. All right, but point is, so if men are from Mars, then there must be women from Venus. So what does that imply? That means there must have been life on Venus, right? Now, if you go to Venus today, you're going to see a hellhole because of runaway greenhouse effect. So this started about 700 million years ago when essentially Venus's atmosphere started trapping more heat in and then caused a chain reaction which trapped more heat until it became like 900 degrees Fahrenheit and then caused the atmosphere to turn into all carbon dioxide and have massive pressures 90 times of that of Earth on the surface. But for the first 2 to 3 billion years, the planet could have maintained a habitable environment. So, you know, back in the good old days, when people didn't have telescopes, didn't know what Venus was like, ancient astronomers have always thought that Venus is Earth's sister, right? It's approximately the same size. It seemed to maybe harbor life. Okay, so the study was presented on September 20th at the 2019 joint meeting of the European Planetary Science Congress in Geneva, Switzerland. So here, Michael Way, and Anthony Del Genio of the NASA Goddard Institute for Space Sciences, GISS, they shared their paper. So what did they do? They created a series of 5 simulations that consider what the environment of Venus would be like based on different levels of water coverage. All right. So in 3 of the 5 scenarios, they assume that the topography of Venus is much the same as today. And essentially, they can also consider a scenario with Earth topography and a 310-meter ocean, and another where Venus was entirely covered in an ocean of 158 meters. So in the end, all 5 simulations indicated the same thing. Venus would have been able to maintain stable temperatures from about 68 degrees Fahrenheit to a high of 122 degrees Fahrenheit for about 3 billion years. That is enough time for life to form. So now, were it not for a series of events that caused 80% of the planet's surface to be resurfaced, which led to an outgassing of carbon dioxide contained within the crust, it might even be habitable today. So, as Wei explained, our hypothesis is that Venus may have had a stable climate for billions of years. It's possible that the near global resurfacing event is responsible for the transformation from an Earth-like climate to the hellish hothouse we see today. So, so what exactly happened? What happened like 715 million years ago? We don't know. Apparently, there was some geological event, and this is kind of a strange cosmic mystery. We don't know what happened to Venus 715 million years ago. But apparently, something happened that caused 80% of the planet to rearrange itself. And this caused a large amount of magma to burst up and release a huge amount of carbon dioxide in the atmosphere, causing a runaway greenhouse effect. So, what happened? No idea. So, now, this is kind of scary for us here on Earth, now think about it, because what if the same thing happens? What if some event triggers a massive resurfacing of Earth, some geological disruption, say, and causes, because we actually have like tons of gas, carbon dioxide gas, stored in our crust and our oceans as well. And by the way, Earth has done this in the past. So for instance, the creation of the Siberian traps 500 million years ago pretty much led to a mass extinction. Yes, we all heard of the dinosaurs, but there's stuff like this that's happened that's wiped out life before. Just nothing hitting Earth is just stuff like this. Siberian traps 500 million years ago, okay? But of course, that didn't cause all life to end. It didn't cause a runaway greenhouse effect. But what if something like that happens? That'd be pretty wild. Okay. So, I mean, and on Mars, Mars, what happened? I mentioned this earlier. No magnetosphere. So what does that mean? That means that the atmosphere got stripped away and it went cold and dead. So Venus suffers some resurfacing event or a series of them. Mars suffers atmosphere being stripped away. We're lucky so far. Hopefully we stay that way, right? Yes, hopefully. So okay. All right. Is it time for a break? Because I feel like wiping my nose again. To you guys. I wanted to talk to a little more about alien stuff, but I think we're just going to have to hold off on this. Mainly because my nose is bothering me, and also, look at the studio time. Come on. It's almost, time to go, right? So, with my typical ending, I will still say this. Look up, because you never know what you will see. Just like I did today. I did not see anything, by the way, but the stars look nice. You guys may see something else. If you do, please let me know. SG2 on Space, episode number 46. So, as always, next Thursday, every Thursday, 8 to 9 p.m. Houston time. Feature Action One Media. All right. And also, thank you all for those who support me on Patreon. I do not say this, but Patreon, if you want to support me, is patreon.com/SG2 on Space. And for those of you who are already supporting me, I warmly thank you, and we'll talk to you about further details regarding what can be offered. So with that, I will say good night to you guys, and look up, because you never know what you will see.
Peace, brother Atum Ryan. You tuned in the Action One Network.